This video is how to perform power and sample size calculations in Quantum Excel. Before you can perform power and sample size calculations, Quantum Excel must be running. You can tell that Quantum Excel is running if you see QXL Monte Carlo, QXL Stat Tools, and QXL DOE in the Excel ribbon. If you don't see them, then you need to start Quantum Excel, and there's a separate video for that. As a setup for this, I have a picture of Arnold Palmer. Many of you might think that's just the name of a drink, but he was a famous golfer. Here's a picture of him playing golf as a yeoman in the Coast Guard many years ago. Unrelated, I play golf and I use a golf ball that cost $1. And so this blue golf ball here, this $1 golf ball, is my current golf ball. And let's say that someone comes up to me and says, hey, if you were to change to this $5 golf ball, then you would be able to hit the ball further and you would be better in golf. So the better golf ball cost $5. Of course, before I spend that much money on a golf ball, I'm going to validate that it does in fact go further by doing a t-test. Before I do that t-test, I need to know how many samples I need to collect before I can do the t-test. The things that we need to know before we do the sample size calculations are listed on the right-hand side of the screen. The first thing is the desired power. Most people go with a 95% or a desired power of 0.95, but you're welcome to change that. The other thing I need to know is the difference I'm trying to detect. The difference I'm trying to detect is the smallest meaningful change that the distance in the golf ball goes on average compared to the $1 versus the $5 golf ball. In other words, if the better golf ball doesn't go at least 20 yards further, then it's not interesting to me. Anything less than 20 yards will not change my score very much in golf, and therefore I'm uninterested in it. So if it doesn't go at least 20 yards further, it's an uninteresting result. Then the last thing I need to know is the standard deviation. Technically, it's the population standard deviation. And unfortunately, I'm a very bad golfer, so my population standard deviation is around 25 yards. Now that we have those three pieces of information, it's quite easy to calculate the power and sample sizes. To do power and sample size calculations in Quantum Excel, click on Hypothesis Test, Power and Sample Size, and Two-Sample T-Test. At the top, Quantum Excel asks, what would you like to calculate, the sample size, the power, or the difference? In this case, we're going to start with the sample size, but we'll come back and talk about that in more detail in a moment. Then I can type in the power. In this case, the power is 0.95. Again, I can put any value in between 0 and 1. The difference I'm trying to detect is 20 yards. Anything less than 20 yards is uninteresting to me. And then my standard deviation is going to be 25. The way I phrase the test is a one-sided t-test. And so I need to go to Advanced Options, and I need to click on greater than, indicating that I'm only interested if the difference is greater than 20 yards. And then I click on Finish. When I click on Finish, Quantum Excel will give me the answer. The calculated sample size is 35, and there's a note here that says the sample sizes for each group. That means that for me to perform this t-test, I need to go out and take the $1 golf ball, and I need to collect sample 1, sample 2, sample 3, all the way through sample 35. And then I need to take the $5 golf ball and collect samples 1 through 35 as well. Right next to that is the difference I'm trying to detect. The difference I'm trying to detect is 20 yards. My target power was 0.95. The actual power was 0.95236. The reason they're not the same is that sample sizes are only available in integers. So a sample size of 34 was a little bit below my target power, 0.95. The sample size of 35 was a little bit more than my target power. Instead of 0.95, it's 0.95236. Below that, I get a power curve. The difference that I'm trying to detect is right here at 20 yards, and you can see that there's a blue dot there. If the difference I was trying to detect was less than 20 yards, what you can see is the power drops off quickly. So for example, if I was trying to detect a difference of 10 yards, well, that would take me up to a power of about 50%. And if I was trying to detect a difference of 25 yards, well, the power would be almost 100%. Quantum Excel is not limited to only calculating the sample size. You can also rephrase the question in a different way. For example, if I click on Stat Tools, Hypothesis Test, Power and Sample, and Two-Sample T-Test, I might know that I have the time to collect 20 data points. And given that I have the time to collect 20 data points, what would be the power? So instead of calculating the sample size, I click on Power, and I put in the sample size for each group, which I said that I had time for 20. The difference is the same, so I'm trying to detect a difference of 20 yards. and the standard deviation is the same, and it is 25 yards. And when I click on Finish, Quantum Excel will do the power analysis for me, and it says that given that I only have time for 20 samples, the power is only 69%. And that is how you perform power and sample size calculation in Quantum Excel.